Hello everyone, myself MS Bahaudimal, Assistant Professor from AADS Department, Subject Code CRA 332, Drone Technologies, Unit-2, Drone Configurations. Drone configurations. Drones comes in a variety of configuration which are determined by the number of motor, their placement and the drone's intended purpose. The configuration impact the drone's flight stability, payload capacity and overall performance. That are single motor configuration, multi-rotor configuration, fixed wing configuration, then hybrid VTOL, that is vertical takeoff and landing configuration, then cosine configuration. This is the comparison of all set of drone configurations. The first one is configuration, then rotor stability, payload capacity, and flight efficiency, then use case. Single rotor, in this rotor using one rotor, then stability is moderate, payload capacity high, flight efficiency high, then use case cargo and long range. Next one is trihopter, rotor 3, stability low, payload capacity low, flight efficiency moderate, use case hobby, then small task. Quadcopter, rotor 4, stability high, payload capacity moderate, flight efficiency moderate, use case photography and consumer drones. Hexacopter 6, rotor, then stability very high, payload capacity high, then flight efficiency moderate, use case industrial inspection. Then octohopter, rotor 8, stability extremely high, payload capacity very high, flight efficiency lower, then use case cinematography heavy lift. Fixed wing, rotor none or wings, then stability high, payload capacity low moderate, flight efficiency extremely high, then use case long range and mapping. Then hybrid VTOL, rotors varies, then stability high, payload capacity moderate, flight efficiency high, then use case search mapping and rescue. Then cosine, the rotors 2 per arm, stability high, payload capacity high, then flight efficiency moderate, use case compact and industrial. Then choosing the right configuration. The right drone configuration depends on several factors. First one is mission requirements. Fixed wing drones are ideal for long range missions, while quadcopters or hexacopters are best for tasks requiring stability and hover. Then payload. Heavy payloads typically require hexacopters, octohopters, or single rotor systems. Then flight duration. Fixed wing and hybrid VTOL drones offer the longest flight times due to efficient lift from their wings. Then environment. Multi-rotor drones are best for tasks is in confined or urban areas where vertical takeoff and landing are required. Thank you.